Okay, call this number 4. This factorization technique number 4. And write the beginning special binomial. You can already see that difference of two squares is a technique that I've already discussed last year. But again, I'm putting this in order. So at the end of the video, when I start summarizing everything and fitting everything together, you'll be able to see exactly how everything fits. Now with special binomials, you see sometimes you will be, and remember what it says here, binomials. So therefore, what you must keep at the back of your mind, two terms. Right? I'm going to make a very important conclusion at the end. So when you're given these questions, sometimes you think you're unable to solve them. At the point when you think you can't solve them, that's when you must think of special binomials, because you will employ these techniques to solve those questions. Difference of two squares I've already discussed extensively. You have two terms and they are both perfect squares and they are separated by a minus sign. Then you will employ the square root of the first term, square root of the second term, square root of the first term plus the square root of the second term in one bracket, and in the second bracket will be the square root of the first term minus the square root of the second term. I just want to add one more word here, something called an identity. We've talked about equations, we've talked about expressions, we've talked about inequalities. The last thing that we're going to talk about is an identity. An identity is a mathematical statement that is true for every value of the variable unless otherwise stated. So if you look here, this identity will hold true irrespective of what the value of A and what the value of B may be. Understood? So, and the reason I'm saying that for this mathematical statement specifically, because I don't have a comma here and some restriction. If I did, then obviously the restrictions would apply. But now we don't have that, so therefore it will be true irrespective of what the value of A and B may be. So that's the reason why we say whenever we use the word identity, all you need to look for is a perfect square, another perfect square separated by a minus sign. Therefore, you'll just apply this identity. There are just some more formal words that you'll start using when you get to university. The last one here that I want to discuss is the sum and difference of cubes. This will be very important when you get to grade 12, when we start working with the cubic function. So make sure you understand this here. Again, I said here too, we find the cube root of the first term and the cube root of the last term and substitute it into the relevant positions. So here you can see you got a squared minus ab and b squared. So all you got to do is find the cube root of the first term, gives you what? A. Find the cube root of the second term, gives you what? B. In your second bracket, you'll just be a squared. So take this and squared. It'll be a times b plus b squared. The only thing that's very tricky about this, you see the sign of the middle term here in the second bracket is the opposite to the sign of the question. And the sign here is opposite to the sign of the question. But the sign in the first bracket is the exact same of the question. So if you look, if I have to elaborate on this, let me write it down here. See, a cubed minus b cubed, I'm not looking at the identity, will give you cube root the first term a, cube root the second term b, copy the sign in the first bracket. In the second bracket, you'll have a squared, change the sign, multiply both the terms ab and square the last term, plus b squared. Right? Now it's very important to see here, what is the first term? X cubed. What is the second term? 64. So I want you to, don't focus on the sign, don't focus on the minus sign here. Let me give you some reasoning, right? Remember when we said x plus 1 into x minus 1? We said we're not actually focusing too much of the sign. We just square the first term, x squared, square the last term 1, and add the minus sign there. It's the exact same idea. So we're not actually focusing too much of the sign, we're just focusing on the values, the specific values in the term. These are just separating them. Right? For all of the other products and stuff, we do focus on the sign, like the perfect square. But here we don't. Right? So for the difference of two squares and the sum and difference of cubes, we don't. So if I look at this question here, if I cube root the first term, it gives you x. If I cube root the second term, it gives me 4. Since I have a minus sign, it'll be x minus 4, square the first term, x squared, multiply the first term and the second term gives you 4x. Then I must change the sign, plus, square the last term, plus 16. And that's how we get the factorized form when you're given a sum and difference of cubes. This is not tested at grade 10. I'm just reminding you because this will be a grade 12 concept. Right, now we have everything that we need. If I zoom out here, we have everything that we need